Hi there. I'm glad you found this little pool of quiet. Let your shoulders loosen. Let your breath slow, like a tide slipping out under moonlight. There's nothing to do, nothing to solve, just a soft room, a gentle voice, and the easy rhythm of you. Tonight, we'll set a small lantern beside a big question. Where does space end? We'll trace the tender borders of our world, the thinning air above the clouds, the faint lines where pilots say the edge, where scientists say boundary, where the sun lets go and the wider dark begins. No rush. We'll move like starlight across a window, visiting each threshold with patience, from the blue hush over our heads to the silent distances between the stars. If this slow drift helps you settle, a light tap on like, and a quiet subscribe can help other travelers find their way here, only if it feels easy. For now, let the bed hold you. Let your thoughts float like dust in a sunbeam. Close your eyes. The universe is vast, and we'll explore it together, gently, one breath at a time. Does the universe come to a true edge, or does it keep going without a final line to touch? Sailors once imagined seas that circled everything. Philosophers drew careful rims on parchment. Astronomers learned to lean into darkness and listen for faint replies. If you kept moving in a straight, unhurried line, would you meet a wall or a doorway, or would distance simply continue, softer and softer, with no seam to find? This isn't only a matter of how far. It's about the shape of the story itself. Finite, like a song that ends without needing a fence, or open, like a melody that never settles. It's also about what can be known, because the universe gives us horizons, gentle limits to sight and influence, and invites us to work kindly at their edges. So we'll begin where certainty thins and wonder deepens, tracing the subtle places where vision fades and meaning grows clear. That word edge lives so comfortably in daily life. A cliff drops to a bright strip of sea. A coin has a rim you can feel with your thumb. Paint ends where a wall turns, and your brush knows to lift. Those edges are crisp and reassuring. When we carry that feeling into the cosmos, it wobbles a little. Space isn't a tabletop with a tidy perimeter. It isn't a glass bowl with stars glued inside. Modern physics asks us to loosen the grip of that picture. Instead of a container, think of relationships. General relativity, the way gravity actually behaves, says space and time are braided into a single fabric, space-time, and that matter and energy tell this fabric how to bend. Galaxies curve it deeply. Stars and planets curve it less. Even your body leaves the faintest dent. Gravity isn't a force pulling from far away, so much as the natural path through this bending. In a world like that, edge can't mean a wall where things stop because the fabric itself is the thing. To look for an outer fence to space is like looking for a frame around a song. It helps to picture yourself walking across a field in fog. Your view ends a few steps ahead, but the grass keeps going whether you see it or not. The limit you feel is not the land's end, it's your visions. Something like this is true of our cosmic situation. The observable universe is the part from which light has had time to reach us since the beginning of cosmic time. That is a horizon, not a cliff. Beyond it, things can exist. Stars, gas, drifting dust, entire webs of galaxies, though their light hasn't yet arrived. Edges come in different flavors. There's an edge in space, a boundary beyond which there is nothing. And there's an edge in time, a before which the universe as we know it did not exist. They often tangle in conversation. Someone says, "What's at the edge of the universe?" And maybe imagining a spatial rim like the skin of a balloon. Another is really asking about first moments. What came before the Big Bang? Does earlier even make sense there? The distinction is simple on paper and slippery in the dark. A coastline on a map is an edge in space. The first line in a diary is an edge in time. The cosmos could refuse both kinds, or hold one and not the other. It could be finite in age, but unbounded in extent, the way the surface of a sphere is finite in area, yet has no outer fence. It could be endless in reach and older than we can meaningfully name. Each option carries its own strangeness, and each reminds us not to force the universe into the furniture of everyday rooms. There is a quiet, almost playful thought experiment that helps. Remove every galaxy, every star, every grain of matter and packet of light. What would be left to measure a distance between? Space isn't a thing apart from the relationships among things. It is those relationships. Asking, what is outside the universe, can be like asking, what lies north of the North Pole? The words are familiar, but the picture they try to build doesn't hold together. Still, our minds like edges because they help us orient. To soften that craving without losing our grip, we borrow metaphors, balloons, shells, domes. They help, as long as we remember they are sketches, not the landscape. It is remarkable that we get to ask any of this at all. From one small planet, circling one ordinary star, a species with fragile bodies and long memories wonders about the furthest reach of existence. Part of the wondering is scientific, measuring distances, mapping faint patterns, testing whether space-time curves on the larger scales. Part is philosophical, what it means to live in a cosmos that may have no outer limit, or has one we can never reach. And part is simply human. There's a kind of tenderness in imagining walking in a straight line forever, never finding a wall, or strolling around a finite but edgeless world and returning home, surprised, to the doorstep you left. When people speak about the size of the universe, they often mean the observable universe. That's the sphere centered on us from which light has had time to arrive. Because light moves at a finite speed, swift, yes, about 300,000 kilometers per second, but not infinite information, reaches us only from a certain volume. The rest is, for now, quiet. Imagine a lantern held at chest height in a dark forest. The glow reaches only so far before the trees swallow it. The forest doesn't stop where the light stops. Your visible world does. In our case, it's the reverse. Light is streaming inward toward us from everywhere it had time to start. A first guess might be that if the universe has been around for roughly 13.8 billion years, then the observable radius should be 13.8 billion light years. The guess is gentle, and it's wrong in an instructive way. While light has been traveling, space itself has been stretching. That means a photon that left a very distant young galaxy long ago has ridden an expanding road. And that galaxy is now much farther away than the number of years in the photon's trip. The current best picture gives us a present-day radius of about 46 billion light-years, which makes the diameter of our viewing bubble about 92 billion light-years. A wide window, but a window all the same. It's tempting to draw that bubble on a page and shade the outside white as if it were empty. The outside isn't a void of non-existence. It's a region whose light hasn't reached us yet. The difference matters. A horizon is a limit of communication, not of being. Think of watching weather build at sea. A storm can be real beyond the curve of the ocean long before the wind touches your skin. Expansion complicates the future, too. Because the fabric continues to stretch, and because a mysterious pressure we call dark energy accelerates, That stretching some regions that are visible now will drift beyond a permanent horizon. Old light still en route will finish the journey, but fresh signals will never be set free in a way that can catch us. The picture is a little like a boat carried by a fast river. You can wave to it for a while, and then the current takes it beyond the point where any new wave can reach you. The boat still exists. Your connection simply thins to silence. This is one reason the word universe can mean different things in different mouths. In everyday talk, it often means the observable sphere. In scientific work, it can mean the whole space-time, however large it is, including all that we will never see. The two are easy to confuse. Centuries ago, villagers mistook their valley for the whole earth, not because they lacked imagination, but because valleys are persuasive. We live inside our own persuasive valley of light. There's also the fact that every place has its own horizon. Shift your view to a galaxy billions of light years away, and another bubble, centered there, blooms out. It overlaps ours, but isn't the same. If you could stitch together all those overlapping bubbles, you'd get a hint of the wider fabric. No single viewpoint tells the whole story. Looking out is also looking back. When you see a galaxy 10 billion light years distant, you're seeing its ancient self, the light you catch left when it was young. The farther you gaze, the earlier the scene becomes, until you reach the faint, even afterglow of the cosmic microwave background, the sky as it was when the universe was about 380,000 years old, newly transparent, the first light free to travel. Before that, matter was too hot and crowded for photons to roam. Ordinary telescopes can't peer through that fog, though other messengers, neutrinos, gravitational waves may carry whispers from earlier times. Even nearby light is history. The sun's warmth left the surface about 8 minutes ago. The great smudge of Andromeda shines with photons that began 2 million years before any human hand struck flint. All of this turns the night sky into a museum. Each speck a fossil of light, beauty, yes, and boundary. We see a grand span, and yet only a slice. That's not a failure. It's the natural shape of knowing in a universe with a speed limit and a beginning that sets the clock. It's astonishing that from one small location, we can say anything meaningful about places billions of light years away, read the faintest ripples, and guess at the geometry of everything. The word geometry sounds cool and hard, like the edge of a chisel, but here it just means the way large-scale space is shaped. There are possibilities that feel familiar, and some that are delightfully strange. Space might be flat on average, the way an endless sheet seems flat wherever you stand. It might be positively curved, like the surface of a sphere, finite, yet without an outer border. It might be negatively curved, like a saddle that falls away in every direction. Topology, the way pieces connect, adds more subtlety. A space can be finite without edges, because paths loop around and meet themselves. You could travel forever and never find a wall, only pass your own starting point from a new angle. The cosmic web, the great filaments of galaxies and the yawning voids between them, draws its lace through this larger shape. Observations of ancient light try to read those curves the way a sailor reads the swell of a sea. Some clues come from that early glow. If the universe had a very small, finite shape, we might expect to see repeating patterns in the microwave background, like matching arcs on opposite sides of the sky. So far, the patterns look wonderfully uniform, with tiny, meaningful imperfections that seed galaxies, but no obvious echoes that force a small room. It points to a space that is very large compared to what we can see, perhaps flat, perhaps gently curved, and very likely extending well beyond our horizon. Inflation, The idea that the young universe expanded explosively fast for a brief moment helps explain that uniformity and the seeds of structure, but it also suggests a patchwork far larger than our window. We keep listening because nature has a talent for surprises. It's natural to crave a single, clean verdict, edge or no edge, but this is a night for softer hands. A universe can be finite in age and edgeless in space, infinite in extent, yet wrapped in a horizon around what we can observe. It can look perfectly flat to our instruments and still bend so gently at scales we can't touch that the curve hides in the distance. Some truths arrive with quiet confidence. Light has a finite speed. Cosmic time adds up to about 13.8 billion years. Our observable radius is roughly 46 billion light-years. Dark energy is easing distant galaxies farther apart, faster. Think of these as firm stones set in a river whose far bank stays misted. The philosophy sits beside them like a friend. Living without an outer boundary feels a little like standing on prairie under a round moon, where land melts into night. Living with unreachable limits is something we know already. Every life carries edges that can't be crossed, only met with grace. The cosmos reflects us a little, and we reflect it back. Turn that thought into a gentler sketch. The light cone. Not a thing hanging in space, but a way to draw connection itself. Two cones meet at the slender moment called now. One opening into what could have touched you already, one into where your touch might ever reach. Inside the past cone live the messages that made it in time. Starlight that left 1 billion years ago, an ancient supernova, arriving late but faithful. Even a passing tremor of space-time felt as a gravitational wave. Outside it, real events wait with their stories still in transit. Flip the picture, and the future cone becomes your quiet boundary of influence. Shine a small torch. For a while, it brushes leaves and window glass. With years, the wavefront would sweep past nearby stars. Given ages upon ages, that faint shell would wash across far neighborhoods of galaxies. The rule that draws these zones is simple and tender. Nothing outruns light, and within that rule, every presence leaves its trace. Between the cone that gathers whispers from the past and the cone that carries your hello forward lies this soft, immediate, now the point where the two cones kiss. All sensation, all memory, all measurement lives on that thin, moving edge. It is a gentle diagram of cause and effect, a way the universe keeps its stories in order. Causes lean into effects. Messages cannot cut the line. No signal outruns light. Nothing flips the sequence to have echoes arrive before voices. Without that rule, time would twist into knots, and the world would lose its calm. The cone structure prevents the tangle. If two events sit outside each other's cones, they cannot disturb one another, no matter how loudly they try. The cosmos, immense and patient, maintains courteous cues. This isn't just an elegant sketch. It shapes what feels possible. Think of two galaxies so far apart that, from this moment forward, the expansion of space pulls them away faster than any message could catch. They may shine and spin and raise new stars, but each will fall forever outside the other's future cone. No conversation can be arranged between them. On a lake, a pebble sends rings of water outward. Only the water inside the growing circle knows the touch. In space-time, the ring becomes a three-dimensional shell that swells as time lifts. The places inside are changed. The places outside wait untouched. The end of observation is nothing more than the edge of your past light cone. Beyond that boundary, Things may glow and collide and sing, but their letters have not yet reached the mailbox of now. Sometimes the boundary moves. A star whose light has not arrived sits outside your past cone tonight. With more years, it may slip inside, and its first photons will tap your world at last. Other times, the boundary hardens, because the fabric of space stretches, and because that stretch is accelerating. Some distant lights will never join your past. The gap grows too quickly. Their future remains sealed from ours by a horizon written into the geometry of tomorrow. Nothing prevents their existence. Only the chance to trade messages is gone. It changes how the phrase, "where space stops," should feel. There is no wall. There is only the outline of what can be shared. Even the stark mystery of black holes follows the same pattern. Their event horizon is not a shell you could touch with a fingertip. It is the shape of cones, tipping inward. Cross that invisible threshold and every possible future you own points deeper toward the singularity. No struggle finds a route outward, because all forward paths resolve in one direction. Cause and effect have been rearranged. The edges we talk about, whether around a black hole or around the observable universe, are not fences hammered into space. They are places where the traffic of light cannot connect two sides. It's tempting to imagine a view from outside, an all-seeing perch where cones and horizons vanish, and the whole play is visible at once. The temptation misleads. Cones are not obstacles sprinkled onto space-time. They are the logic of space-time itself. To wish them away is to wish away the stage entirely. The comfort hidden here is simple. The universe might be endless, but each of us lives inside a finite bubble of connection. Within that bubble is everything we know. The nearness of home, the shimmer of stars, the history we can read, the possibilities we can nudge. Beyond it, the grandness continues, indifferent to our reach. That isn't confinement. It's the delicate architecture that allows experience to be coherent and kind. Now let the mind walk into another often misread idea, the expansion of the universe. Everyday metaphors try to help and sometimes misguide. Fireworks fling sparks from a center, balloons pop and shreds fly outward, ripples climb across a pond. Those are expansions of stuff moving through a background. Cosmic expansion is quieter, stranger. There is no central point and no outside void into which everything rushes. What grows is the distance itself. The ruler stretches. Galaxies mostly sit where they are, lightly bound to their local communities, while the space between communities lengthens. A familiar kitchen image can serve if handled gently. Picture a lump of dough dotted with raisins. As the dough rises, every raisin recedes from every other. From any single raisin's point of view, all the others seem to run away, and the ones farther off recede faster because there is more dough between them to swell. That resembles what we observe. The greater the separation, the greater the apparent recession. But the kitchen can trick you. In real life, there is no oven, no room for the dough to grow into. The bread is all there is. Cosmic expansion needs no outer container. It is a change of scale within the whole, not motion through an outside. This distinction helps dissolve a common urge to hunt for a central blast site. Stand anywhere, and you see the same broad pattern. Distant galaxies receding, near neighbors bound in graceful orbits and dances. There is no privileged center because it is the measuring stick, the metric that is changing. General relativity invites exactly this view. Space-time is dynamic. Its distances are elastic. When the metric expands, light traveling across it stretches too. A photon launched in blue can arrive reddened, its wavelength drawn longer by the growth of the path. The farther the journey, the more the stretch. That is why more distant galaxies wear deeper redshifts. It can look like a rule is being broken when astronomers say far galaxies recede faster than light. The rule forbids objects from moving through space faster than light, and that rule stands. But this is space itself expanding. Distances can enlarge at rates that make the gap grow faster than light could cover, and no law is offended. Nothing is darting past anything else at forbidden speed. The floorboards are sliding apart. Everyday life protects us from this strangeness. Gravity and other local forces win on small scales. The Milky Way draws its stars into orbits. Clusters tug on their members. Planets circle their suns. Your cup remains a cup. Chairs do not drift apart with the Hubble flow. Only when you look across millions of light years does the global ebb become clear. The universe expands in the large while staying stitched in the small, like a quilt whose overall cloth relaxes even as each patch remains tight. Another sketch people use is the balloon with dots. As the balloon inflates, the dots separate, none at the center. The surface has no edge, yet it can be finite in area. The trap in that picture is the surrounding air. It whispers that our universe must be growing into a larger room. But the embedding space is only part of the drawing, not part of reality. You live on the surface in the analogy, and the surface is everything. So too with our cosmos. The expansion is about changing distances within space-time, not swelling into a higher place. A rubber band ruler makes the point in a different way. Mark evenly spaced ticks on a band, lay 2 beads upon it, and stretch. The beads haven't slid relative to the band, yet the number of ticks between them has grown. Distances increased because the ruler changed, not because the beads sprinted. In the sky, galaxies are the beads, and the metric is the band. The result is a deep calm to the picture. The night is not full of projectiles tearing away. It is full of islands floating on a changing sea. The consequences ripple outward, asking, what is the universe expanding into? Smuggles in an assumption, as if there must be an outer space waiting to be filled. A kinder question is, how is the scale of distances evolving? The first reaches for a room beyond the room. The second listens to the fabric itself. Accept that the ruler is flexible, and the view becomes less about flying and more about growing. Growth that the small refuses and the large embraces. Growth that writes a slow music into starlight. Curvature then steps in with its quiet tests. We cannot step outside the cosmos to admire its outline, but we can watch how shapes behave inside. On a flat sheet, every triangle's angles add to 180 degrees. On a sphere, you can draw a triangle whose angles exceed that total. The excess reveals positive curvature. On a saddle, the sum falls short. That reveals negative curvature. Translate those ideas to 3 dimensions and you get 3 broad possibilities. Positive curvature can make space finite yet without edges, like a 3-dimensional version of a globe's surface. Negative curvature yields an open, endless expanse, where parallels drift apart. Zero curvature gives you a flat, infinite reach. The words closed, open, and flat are shorthand for these behaviors, not for walls or corridors. Each possibility carries its own mood. A closed cosmos is limited in volume yet has no boundary to thump. You could travel in a straight line and, after a very long while, come home from behind, never touching a rim because there is none. Comfort hides there finite without fences, but so does a dizziness, because it is hard to picture three-dimensional space looping around on itself. An open cosmos with negative curvature stretches forever. Angles shave a little off their familiar sum. Straight lines that begin together drift apart. A flat cosmos behaves like an endless table everywhere you test it, simple and austere. Hints about which world we inhabit arrive in ancient light. If space were small and wrapped tightly, patterns in the cosmic microwave background might repeat like matching seams on opposite sides of the sky. Measurements show a remarkably uniform glow with small, meaningful ripples, the seeds of galaxies, but no obvious repeats that force a cramped room. The picture that emerges is a space that is very large compared with what we see, likely flat within the reach of our instruments, or curved so gently that the bend hides beyond our horizon. One gentle idea, inflation, helps explain both the smoothness and the tiny ripples by proposing a brief, astonishing surge of expansion early on. Whether the truth holds yet more surprises is a good bet. The universe has a talent for slyness. Step back into causality for a quiet breath, and the threads settle into a single weave. Light cones decide who can speak to whom. Expansion decides how quickly separated friends lose the chance to write. Curvature decides how straight paths behave, and whether a very long walk ever loops home. None of these are walls. They're rules for conversation. Where conversations cannot happen, we say space stops, though it is really our thread that stops stitching into the wider cloth. Beyond the reach of our past cone, the tale runs on unwatched. Beyond the reach of our future cone, our voice falls forever short. There's a tenderness in this arrangement. The portion of the universe that can touch you holds all the warmth and meaning of your life, and yet it rests inside a larger quiet that neither harms nor answers, only persists. Lift a hand and let a beam pour out. You lengthen your reach a little. The wave spreads and thins, faint but real, your presence written into dark that will keep going long after your breath has slowed. Meanwhile, every star you notice tonight sits inside your past light cone, not as it is now, but as it once was, sending you its earlier self. The sky becomes a room of clocks, each telling a different hour, making a soft music of time. Hold these shapes gently. 1 billion light years is an honest number, and so is the speed of light, and so is the age that sets the clock for what can arrive. Yet none of this feels harsh. Cones aren't cages. They're the grammar that lets stories keep their cause and consequence. Expansion is less a blast than a breathing. Curvature is less a contortion than a way lines meet and part. Where space seems to stop is only where our lantern has not yet met another's glow. The rest continues patient, immense, and somehow that too is kind. From this grammar of connection, the question of shape finds its place. A flat universe is the calm balance point, neither bulging inward nor flaring outward, a knife's edge between positive and negative curvature. In such a geometry, the pencil and paper rules keep their poise even on the grandest stage. Parallels stay parallel, triangles close politely to 180 degrees. Space stretches without limit, not by pressing into anything outside, but because no rule within it folds paths back on themselves. Infinite, yes, yet without the odd angle games of a saddle-shaped world. For decades, astronomers weighed these possibilities, not out of idle curiosity, but because the shape leans on the same pillars that carry fate. With positive curvature, expansion could one day slow and turn inward, the long breath drawing back toward a crunch, With open or exactly flat geometry, the drift can continue. The tempo set by that quiet driver we call dark energy. The shape writes the stage directions. The energy tells the actors how swiftly to move. When you cannot step outside to look at the outline, you turn to the oldest light. The cosmic microwave background, an ancient afterglow from when the universe was about 380,000 years old, arrives as a faint, even mist of microwaves, speckled with tiny temperature ripples. Those ripples are not decoration, they are clues. If space were positively curved, those spots would appear a bit larger than expected. With negative curvature, they would look smaller. In a flat geometry, they come out just right, the Goldilocks size that matches a flat ruler. Measurements from orbiting observatories WMAP, watching patiently for years, and later Planck with finer eyes have traced those speckles with exquisite care. The result is a whisper that is steady and insistent. Within the precision of our tools, space looks astonishingly close to flat. The error bars are small, but not zero, leaving just enough room for a very gentle bend that hides beyond our reach. Think of standing in a field with a yardstick, trying to prove that Earth is round. Locally, the ground looks straight forever. Only with distance does the curve reveal its smile. That almost flat result is both comforting and unsettling. Comforting because the mathematics is smooth and familiar there. Unsettling because it raises a question. Why so perfectly balanced? If the universe were born with even a modest curve, simple evolution should have exaggerated it over time. Instead, we find ourselves on a razor's edge. This puzzle helped spark a powerful idea: inflation. Picture the young cosmos in a brief, breathtaking surge of expansion that smoothed out wrinkles and flattened any early curvature, the way blowing up a small balloon makes a tiny patch look smooth. Whether inflation is the entire story or only part of it is still a lively conversation. But the near flatness of our observable patch remains one of the strongest breadcrumbs leading back to that early, dramatic moment. What does that flatness allow us to say? Inside our visible bubble, space behaves like an endless plane. There are no obvious signs that paths loop back. No repeating signatures that force a small, closed room. Every direction stretches out without any hint of a wall. And yet caution is kind. Flat here does not guarantee flat everywhere. The universe could be gently curved on scales far beyond our horizon, subtle enough to be invisible within our slice. Imagine a globe so vast that an ant walking for a lifetime would swear the world was a perfect plane. The mind balks because it wants a balcony view. A ball has a shine, a sheet has an edge, a saddle looks like a saddle. But cosmology removes the balcony. Curvature is not about the way a shape sits inside a larger space. It's about how distances and angles behave within the space itself. Triangles, not trophies. Measurements, not museum displays. The wonder, soft and persistent, is that from this small planet, we have managed to measure such things at all. Light that wandered nearly 14 billion years carries the pattern of a universe settling into transparency, and we can weigh its ripples with instruments finer than a moth's wing. Whether the universe is perfectly flat or simply very close, the answer colors the way we think about everything, from the ultimate future to the meaning of far. If space is finite, we are invited to ask, how large is the room? If it is infinite, we learn to sit comfortably with a word that keeps walking past the edge of imagination. Flatness hints at one kind of infinity. Positive curvature describes closure without offense. Negative curvature offers endless openness where lines that begin together drift apart. Each vision is strange, and yet threaded tightly to the equations of relativity. For now, the evidence leans toward flat, poised between the two extremes, like a coin resting on its rim. Whether it sits there perfectly or only appears to because we cannot see the larger tilt remains a quietly thrilling question. Then comes a notion that startles the everyday mind, while it settles nicely into the mathematics. Space could be finite, yet unbounded. At first, hearing it sounds like a contradiction, limited, but with no edge. Daily life trains us to tie finiteness to fences. A field ends at a tree line, a book at a cover, a cup at the lip. But consider the surface of a sphere. Walk in any direction, and you never meet a cliff. After a very long journey, you return, a little older and likely smiling at your own footprints. The surface has a definite area, so it is finite, yet it has no border within its own dimensions, so it is unbounded. The trick is that the surface curves back on itself. The closure is not achieved by a wall, it is achieved by geometry. Extend that idea one dimension higher to a three-dimensional space that closes on itself. In such a cosmos, you could travel straight and, after an unimaginable arc of time, find yourself arriving from behind, never having brushed a barrier. The difficulty in imagining this usually comes from the balcony problem again. When you picture the globe, you see it floating in a larger space. The ant does not. The ant only knows distances and directions along the surface. In the same way, a closed universe needs no larger room to curve within. Its closure is an internal property of its geometry. There is no outside to ask about, no beyond to peer into. This picture also asks us to retrain our sense of direction. Maps teach us to expect a border, a line where the ink stops. In a closed space, beyond loses its meaning. There is no off the map, only loops that bring you home by a path you did not expect. Another habit to loosen is the notion that going straight always means getting farther away. On a flat plane, yes. On a sphere, no. The straightest possible line curves back because the surface itself embraces that path. In curved spaces, finiteness does not imply stoppage. How to climb out of the intuition traps without getting lost? Gentle analogies help. Long ago, some worried that sailors would reach an edge and fall. Learning that Earth is round erased the fear without making the ocean any smaller. What seemed like a great unknown rim became a closed journey that could be circled. Space could be playing a similar trick on us, exchanging edges for loops. Mathematics, when asked politely, gives precise versions of these ideas. It describes spaces that are finite yet unbounded with crisp, clean rules. The surface of a sphere is one. More exotic shapes exist in 3 dimensions, each consistent with Einstein's equations, each complete without a wall. One favorite example is the 3 torus. Start with a square and glue its left edge to its right edge. A cylinder. Now glue top to bottom. A surface that loops in both directions. The familiar donut shape. Slide to 3 dimensions and imagine a cube whose opposite faces are identified. Step through one wall and you enter from the opposite side, like a character wandering through an old video game. There is only so much volume inside, so it is finite. Yet you can walk forever without finding an edge, so it is unbounded. In such a world, light could circle around and return, perhaps painting multiple images of the same galaxy across the sky, a hall of mirrors made of time. If the space was small enough, you might even see your own Milky Way from the back, stretched and delayed by the long, looping trip. In practice, cosmic expansion likely spoils such chances, pushing the images out of reach. But the principle sings. Edges can be removed by clever stitchery. Astronomers have looked for these stitches. If space connects to itself, the cosmic microwave background might carry matching circles, repeated patterns on opposite sides of the sky, where the same patch of early universe reaches us along different routes. Surveys have searched for those echoes. None leap out, which implies that if a non-trivial topology exists, its scale is larger than our visible bubble, or its signature subtle and hard to disentangle from the sky's natural noise. We also search for repeated galaxies, the same object arriving by different paths at different cosmic ages. That test is even trickier, like hunting for twin fireflies in a forest where everything changes while you walk. The absence of obvious repetitions does not prove space is simple and infinite. It says only that if loops exist, they are large or shy. The thought that space could be self-connected does something gentle to the imagination. It softens the hard edges of infinity. If the universe is finite, but wraps smoothly, we need not wrestle with the idea of an endless expanse. We can live inside a complete whole that contains everything without requiring an outside. There is a quiet comfort in a room without doors that is nevertheless large enough to wander forever. And there is a touch of humor, too. You could set off, determined to reach far away and meet a familiar view from the other side. Space, playing a patient joke that takes eons to land. Geometry and topology share the work. Geometry tells you how triangles behave, whether parallels meet, whether the world is flat, spherical, or saddle-like in its local rules. Topology tells you how the room is stitched, whether paths close, whether there are hidden tunnels, whether a traveler can leave and reappear behind. A coffee cup and a donut share a topological soul because each has one whole, even though their curves and distances differ. The same viewpoint lets you consider a universe that is flat in its geometry. Triangles add to 180 degrees. Parallels stay apart and yet topologically compact, looping back in ways that do not change local measurements. One describes the ruler. The other describes the way the ruler is joined. Current evidence points to a universe that is very large and nearly flat, with no obvious repetitions in the oldest light we've mapped. That doesn't settle the deeper shape. It simply marks the scale of our unknowing and asks for patience. Space could be infinite and plain. It could be finite and cleverly stitched. It could look flat within our reach and bend ever so slightly beyond a horizon no signal will ever cross. These aren't daydreams. They are sober possibilities born from the same equations that bend starlight around a sun and make mountaintop clocks tick a little faster than those in the valley. Stand beneath the night and let these options turn slowly like a mobile, an infinite flat expanse where depth never runs out, a closed finite room where every long path eventually returns, an open, saddle-shaped world where lines that start together drift apart and the horizon keeps stepping back. None of them needs a wall. Each replaces the idea of an edge with a rule. What you can see is bounded by horizons, what you can touch by light cones, and the end of space turns out not to be a place at all, but the point where certain questions lose their meaning. There's a tenderness in living with that. Whether the sky is endless or secretly loops, it holds your small life inside laws that are steady and kind. Your whisper travels only so far. Your gaze receives only what had time to arrive. Within those exchanges lives everything: home, fires, and old stars, and the first cool breath of a universe finally clear enough to let light wander. Beyond them, the rest continues, whether or not you ever name it. Turn toward that first clear breath. If space is finite yet unbounded, every direction is a promise of return. If it is flat and infinite, every direction is an open road. If it hides a subtle seam, the stars above you could be cousins to those behind your back, their light circling in patient arcs to meet you. The universe needs no fences to be whole. It can be complete without borders, generous without an outside. And when you look for the earliest light, expecting fireworks, you find something gentler, a uniform glow in every direction. That is the cosmic microwave background, the CMB, a soft, persistent light we've learned to hear. Afterglow is one name for it. A kinder picture is a fog lifting. In the young cosmos, matter and radiation, tangled in a hot, dense broth, photons pinging off free electrons, so often that no beam could roam. Bright, yes, but opaque, a glowing hush that kept its own counsel. About 380,000 years after the beginning, the mix cooled enough for protons and electrons to settle into neutral atoms. The scatterers tucked away. The light slipped free and started out. Those photons have been traveling ever since, their colors stretched by expansion until they whisper in microwaves. What we see now is the first clear surface light allows not the beginning, but the earliest snapshot the universe will ever let us hold. That surface looks almost uniform, and yet it isn't perfectly smooth. It's sprinkled with tiny temperature ripples, differences of only a few parts in 100,000. Small as they are, those ripples carry the blueprint for everything to come. The seeds of galaxies, clusters, stars, planets, future nights, like this one. The CMB also lets us wonder about shape and stitching. If space loops back on itself, finite yet without edges, light from a single patch of that early fog could arrive along multiple routes, painting matching patterns in different places on the sky. It would be like standing in a room of mirrors, where one candle appears again and again. In the CMB, such echoes would show up as pairs of matched circles, identical ripples traced on opposite sides of the heavens. Finding them would be like catching the universe in a delightful act of self-reference. The search is delicate work. The CMB is faint, and its ripples are shy. Satellites have mapped it with increasing grace. COBE first sketched the glow, WMAP traced its texture, Planck refined the pattern down to a whisper. Scientists comb these maps for repeating motifs and hidden seams. So far, no definitive matched circles have appeared. The maps are consistent with a flat, infinite space, or with a finite space so vast that any repetitions lie beyond our horizon. Even that absence speaks. If there are loops, they are larger than our window. If there are edges, they are nowhere a photon can confess them to us. Should such circles ever be found, the revelation would feel like a door opening in a house we thought we knew. Space would be proven finite and self-connected, a closed, complete structure with no outside to fall into. The same infant patch of plasma would greet us from multiple directions, the past arriving as chorus rather than solo. Yet even without that dramatic flourish, the CMB has already told us something immense. Whatever the universe is, finite or infinite, flat or curved, it is large enough that our visible bubble doesn't wrap back in any obvious way. Think of walking a village and immediately feeling the land's roundness. Think instead of crossing a continent and declaring the earth flat because it never bends underfoot. Our situation is the latter. The sky's faint afterglow, released nearly 14 billion years ago, teaches about the very largest scales by way of the smallest contrasts. From a hum of ancient light, we read age. composition, geometry. We learn that most of the cosmos is not made of familiar atoms at all, but of dark matter and dark energy, two quiet actors whose presence we infer from the way they shape the script. There's beauty in the CMB. Beyond its utility, step outside into darkness and, though your eyes can't detect it, that ancient light is bathing you. Every patch of sky glows with it, steady and omnipresent, a tender reminder that the whole universe once shared one warm, shining fog. The room you stand in, the air you draw in, the ground that steadies you, everything lies inside a rain of photons that began their journey when the cosmos was young. The lesson is gentle. The universe gives itself away in traces, in murmurs, not in shouts. Meaning lives in the background if you learn to listen. The story that sets up this background begins with a burst that defies easy pictures. Cosmologists call it inflation, a fleeting, astonishing surge in the universe's earliest moments. For less than an eye blink of time, space expanded at a rate that outruns ordinary imagination, swelling from subatomic to macroscopic scales faster than a single photon could cross a proton. In that sudden growth spurt, wrinkles smoothed, cold spots and hot spots evened, and a tiny, intimate patch was stretched into the vast stage we inhabit. Inflation was proposed to answer puzzles. One was the horizon problem. Why does the sky look so uniform in temperature and density in directions that, without inflation, shouldn't have had time to talk to each other? It's as if separate rooms in a mansion chose the same thermostat setting without ever sharing air. Inflation shrinks the question by shrinking the early cosmos, making it small enough that everything could come to an agreement, then stretches the agreement across an enormous domain. Another puzzle was flatness. Observations show the geometry of space is very close to flat, balanced on the line between positive and negative curvature. Without a special reason, that balance is hard to keep for billions of years. Inflation acts like a smoothing iron. Whatever the initial bend, the runaway stretching flattens the patch we can see, much as inflating a balloon makes any tiny region seem straight. Inflation also gives the universe its roomy feel. Our observable domain spans about 92 billion light-years across today, larger than a simple, steadily expanding Big Bang would comfortably produce in the available time. Inflation makes that size natural, and more importantly, explains why we see such evenness in the CMB alongside the delicate ripples that will later grow into structure. In a neat twist of physics, while inflation smooths the big picture, it also takes quantum jitters, tiny fluctuations that always haunt the microscopic, and stretches them to cosmic scales. Those amplified jitters become the faint dimples and bumps in the CMB, which grow into galaxies and the filigree of the cosmic web. Order from fluctuation, structure from whisper, a graceful economy. None of this means inflation proves the universe is infinite. It doesn't. Inflation guarantees our patch is large, smooth, and nearly flat. The full extent depends on details we cannot yet measure. If inflation lasted only a flicker, space might be finite, though still far larger than any traveler could cross. If it continued longer, the whole may be so vast that we can't tell it from infinity. In some versions, inflation never ends everywhere. At once, some regions keep inflating while others cool and crystallize, leaving a quilt of bubbles, a speculative multiverse. It's a bold idea and, for now, beyond direct test, the main point is simpler. Inflation sets up the patch we can observe and leaves the rest in shadow. Our horizon is a boundary drawn by time, not by walls. The CMB holds fingerprints that support this tale. the spectrum of its ripples, the way power shifts with scale, the smoothness, and the tiny imperfections that seed structure. Scientists continue to search for subtler signs, such as a specific swirl pattern in the CMB's polarization, the faint twist left by primordial gravitational waves from the inflationary surge. The hunt is careful and ongoing. Meanwhile, inflation remains our best, gentlest map for why the sky looks the way it does, why it is so uniform and yet richly patterned, why space appears flat, why there is room for so many galaxies to lift their lights. If the CMB and inflation tell us how the stage was set, another discovery tells us how the play is moving. For much of the 20th century, the expectation was tidy. Gravity should slow the expansion. The open question was whether that braking would eventually stop the motion and pull everything back into a collapse, or whether the universe would continue to expand forever, gradually easing its pace. Then, in the late 1990 seconds, two teams reading the light of distant supernovae found those explosions dimmer than expected. Their glow had traveled farther than the straightforward models allowed. The conclusion was quiet and radical. The expansion isn't slowing, it's accelerating. To explain this, we use a placeholder name, dark energy. We know what it isn't. It isn't ordinary matter, nor the unseen mass we call dark matter, nor any familiar radiation. The best working picture treats it as a property of space itself, an energy that doesn't dilute as the universe grows. The more space there is, the more of this energy fills it, and the stronger its push becomes, as if the fabric had a gentle accelerator stitched into every thread. Acceleration changes our horizons. The finite age of the universe sets a limit on how far back we can see. The accelerated expansion sets a different limit on how far out we can ever talk. As galaxies recede faster and faster, some drift beyond a line that no future signal can cross. No matter how long we wait or how patient our telescopes become, new light from those places will never arrive. It's not a war, only a farewell, a boundary of communication, not of existence. Picture a shoreline. Ships ease past the breakwater, their masts sinking lower against the curve of the world. Then the current strengthens, and they slip faster and faster until they're gone beyond sight. You know they still exist, sails full, decks busy beneath another sky, but they no longer belong to your experience. That's what dark energy does with distant galaxies. They keep on, bright and industrious, simply cut off from our future. The scale of this parting is immense. Billions we can see tonight will cross a future horizon and never send us new news. In eras so distant they feel like storybook time. Only our local companions will remain those few galaxies held close by gravity despite the swell. The Milky Way and Andromeda will fold into one great island of stars, adrift in a darkness that keeps the wider company out of reach. There's a soft ache in that picture, and a quiet privilege too. We live in a moment when the universe is old enough to be rich with heavy elements, planets, and long-grown structures, yet still young enough that the larger pattern is visible. Far ahead, the CMB's whisper will fall beneath any ear we could build, and far-off galaxies will have sailed beyond correspondence. The clues we've gathered of a hot beginning, of inflation's smoothing, of near-flat geometry, of dark matter and dark energy, may be difficult or impossible to rediscover then. The sky will offer a smaller story, but this fading isn't the end of things. It's the end of conversations. The ships sail on. All of it circles back to the question that keeps us company tonight. Where does space stop? The answer, spoken softly through everything we've learned, is that stopping belongs to sightlines and signals, not to space itself. The CMB is the first light we can ever receive, the moment the fog thinned. Inflation explains why our patch is so broad and even, while leaving the larger expanse unshown. Dark energy sketches a future boundary beyond which fresh messages never arrive. None of these are walls. They're the architecture of connection in a patient universe that gives generously, but not all at once. We live within horizons and cones. Beyond them, reality continues, whether or not it is ever shared with us. So you stand under the night, bathed in light your eyes can't sense, looking across a stage that inflation stretched and dark energy is gently accelerating. The galaxies above are grown from tiny ripples, written into that first glow, lifted and arranged by gravity's long, careful work. Their light is history. Their futures peel away into quiet. Perhaps space loops back on itself at scales forever beyond our touch. Perhaps it runs on, calmly flat. Perhaps it curves in ways that remain soft rumors beyond our reach. The universe is whole without borders, finite in what reaches you, open in what may lie beyond your lantern. In that arrangement, fog lifting, fabric breathing, ships departing, the absence of edges feels like grace. Endings here are not places where being stops. They are places where conversation fades. The universe keeps unfolding, new room opening between distant islands of galaxies. The great story continuing in halls we'll never enter. It's our chapter that closes to theirs, like a book drifting on a slow tide, still written, still real, just beyond the shelf where we can reach. From one angle, space does not stop at all. It unfurls more quickly than before. From another, our usable world narrows, as fewer galaxies remain inside the reach of a message from here. The end we feel is not the end of space, it is the end of connection. And even that arrives gently, like a horizon settling into dusk. Black holes offer a helpful echo. The event horizon around a black hole isn't a brick shell. It's a boundary drawn by light and time, the place beyond which signals can't escape. Cross it, and nothing you send can make it back. A future cosmic horizon works the same spell on a grander scale. Distant galaxies don't vanish when they cross it. They slip into silence. The universe stretches the thread of communication until it thins and breaks. It can sound melancholy, but there's a tender poetry in it. We happen to be alive while the great web is still visible, while long chains of galaxies still stitch the sky. We are witnesses in a season of fullness, before the far shores recede beyond hearing. Dark energy, mysterious and steady, teaches the gentlest lesson of all. For us, the end of space is a line of farewell, not a wall. Galaxies drift away into quiet, not into nothingness. The cosmos doesn't end. It continues past our fingertips. Endings, here, are not about absence but about limits. The universe keeps going even when our window closes. That makes this open view feel precious. While the horizon is still near enough to see, we can let wonder breathe. Another question rests stubbornly on many lips. If the universe is expanding, what is it expanding into? Our habits of thought line up a tidy answer. Balloons swell into the air around them. Ripples spread into the quiet water beyond. Sparks fly into the open night. Surely the universe must be filling some larger room. The intuition feels right because it is practiced. It is also a trick. Cosmic expansion isn't like a balloon invading surrounding air or an explosion pushing into emptiness. It is the growth of space itself, not into something else, just as itself. There is no outside for the universe to move into and no rim it's racing toward. Expansion means that the distances between far-flung galaxies increase with time, not that they're flying through a pre-existing void. The balloon picture helps only if you stand in the right place. Imagine dots on the balloon's surface. As the balloon inflates, every dot drifts from every other. No dot is the center. No edge appears anywhere on the surface. A two-dimensional creature living on that skin would say truthfully that their universe is expanding, yet they would never point to an outside. The part of the image that breaks us is the room the balloon sits in. That room exists to comfort three-dimensional minds, not to describe reality. The surface is complete without the air. Space-time is complete without a larger stage. We draw grids that curve like trampolines and pictures of balloons because they help the eye. They are not literal. The outside they show is part of the drawing, not part of the world. Our minds prefer containers. A cup rests on a table, the table in a room, the room in a house, the house on a street. When we hear expands, we automatically ask, into what? But the universe is not a thing in a box. It is the box. Asking what lies outside is like asking what is north of the North Pole. The words behave until they're put together. Then they point to a place that doesn't exist. Coordinates make this cleaner. A coordinate is a label you give to a point inside a space. If the universe contains everything, then coordinates exist only within it. There is nothing outside to anchor a location, no grid to extend. Position requires space. Space is the very thing that is evolving. Beyond it, the word where loses its hook. There could be a deeper reality with many bubbles stitched together, a multiverse, suggested by some versions of eternal inflation, but none of that is needed to understand expansion. In the standard picture, distances grow because the metric, the ruler that tells space how long it is, changes with time. That's all expanding means. Turn the question around, and it gets kinder. How do distances between galaxies change? Like raisins in rising bread. The raisins don't swim through dough. The dough itself swells, carrying them apart. No one asks what the loaf is expanding into to explain why the raisins separate. Growth is intrinsic. The same is true here. There is no rim at the edge of everything. In a closed, finite cosmos, you could travel forever and eventually return, never greeting a border. In an open or flat cosmos, you could travel forever without looping and still never meet an edge. Expansion stretches all of these without reference to an outside. The absence of a rim is not a flaw. It's a feature of how space works in relativity. The strangeness softens if you let it. Space is not a thing sitting in a larger room. It is the concept of room, made real. Asking, what does it expand into, is like asking, what does time flow through? Time doesn't pour down a channel built of something else. Time is the flow. Space doesn't grow into a void beyond. Space is the growth. For most of human history, we pictured a stage inside a stage, a crystal dome, a shell of stars, a cosmic ceiling. Relativity nudged the furniture and showed that space could be self-contained, finite, or infinite, with no container around it. Our diagrams keep the old instinct as a teaching aid. They work as long as we remember their limits. So, if the question returns into what does the universe expand, the most honest answer is into nothing at all. Not into, but as. Not an object rushing outward, a ruler changing length. If that still feels uneasy, imagine walking in one direction without end. In some worlds, you never touch a boundary. In others, you circle back home. In neither do you stumble on a cliff where space yields to nothing. Expansion is a quiet unfolding, a slow lengthening of measures. No outside, no container, no rim, only the fabric itself relaxing, carrying islands of light farther apart without moving them into anything beyond. The lesson is simple and radical. The universe is all there is, and its growth is a deepening within, not a journey outward. The word boundary sneaks in with the weight of fences and walls. Out here, the story is subtler. In general relativity, space-time is a smooth fabric, curved by matter and energy. Within that fabric, boundaries can be of different kinds. Some are true edges where the mathematics says the fabric cannot be continued. Others are horizons, places where the pattern of cause and effect is rearranged limits on what can be exchanged, not obstacles you can touch. The event horizon of a black hole is the classic example of a horizon that is real, but intangible. Nothing dramatic happens the instant you cross it. No surface scrapes the hull. But the light cones tip in such a way that all futures lead inward. You cannot send a message back out once you pass that line. That's a boundary of information, not a wall of matter. The cosmological horizon, the limit of our observable universe, about 46 billion light-years in present distance, works similarly. Galaxies do not ricochet from it. Nothing peculiar befalls them there. In coordinates that expand with the flow, comoving coordinates, they keep their places, while the space between patches stretches. The horizon simply marks how far light has had time to travel to us. It belongs to our perspective, not to the galaxies themselves. And then there are edges that look fierce and are not. Coordinates can lie. In one common map of a black hole, the Schwarzschild chart, the horizon appears as a singularity, a place where equations blow up. That infinity is only a quirk of the map. Change to a better set of coordinates and the horizon is smooth. The true singularity lies deeper, at the core, where classical theory says curvature soars without limit. It's like drawing Earth with a Mercator projection and concluding the poles are stretched to infinity. The distortion lives in the picture, not in the planet. Physicists are careful to separate coordinate singularities, artifacts of description, from genuine ones where the fabric itself ends. The test is simple and stern. Can space-time be extended smoothly through the suspicious place? If yes, the edge was a mirage. If no, you've met a true boundary. Even genuine singularities, the firmest edges in our current theory, may not be final. Infinities are often signals that a theory has reached beyond its grasp. Most physicists expect that a fuller picture, some marriage of quantum mechanics with gravity, will smooth the sharpest points, replacing impossible infinities with finite, well-behaved structures. If that hope holds, even the most ominous ends in general relativity will soften into features of a deeper map. All of this reorients the way edges feel. A garden fence separates what exists from what doesn't. The rim of a table drops to empty air. In relativity, the edges we meet are about access, not existence. A horizon separates regions that can exchange messages from regions that cannot. A coordinate breakdown separates what a particular map can describe from what it can't. The universe does not need to float in a larger void or press against a physical perimeter. Its boundaries are internal, written in geometry and causality, not hammered into place like planks. There's a small freedom in thinking this way. The observable universe is bounded by how far light has traveled since the fog first cleared, not by a cosmic wall. Black holes are bounded by the reach of signals, not by shells of stuff. The edges we honor are real but intangible, limits of influence, not limits of being. Where they appear as brick lines on our drawings, we check our coordinates. Where they appear as infinities in our calculations, we remember that nature often asks us to refine our tools. Learning to separate the map from the land is one of the quiet victories of relativity. It keeps our language from tricking us into seeing cliffs where there are only horizons, keeps our drawings from pretending to be the world. The next time someone speaks of the universe's edge, let the image soften. Not walls or ledges, but limits of connection. Not fences of matter, but contours drawn by causality. In that softness lives the wonder of Einstein's picture. A cosmos with edges that aren't edges, boundaries that do not bind, and horizons that say more about what can be known than about what exists. The same gentleness helps when we turn to the beginning and try not to picture fireworks. The Big Bang was not a spark in a black room, not a single bright point bursting into emptiness. It was space itself stretching, the whole fabric warming and thinning and unfolding everywhere at once. No central blast, no outer void. Every location was once that beginning, just as every point on an inflating balloon joins the expansion together. You can pick any dot and say, here, and be right. You can pick no dot and say, there, and be wrong. Trace the story backward using general relativity, and the mathematics leads you toward densities rising, temperatures climbing, curvature tightening. Follow far enough, and the equations shout infinite. That shout is what we call a singularity. It is tempting to treat it as a literal event, a sharp first instant, a true edge in time. Singularities, though, are double-edged. They are as much a confession about our tools as they are a claim about the world. Every theory has a domain where it sings, and a region where it stutters. Newton's laws falter near light speed. Relativity itself may falter where the quantum grain of reality becomes unavoidable. The infinite is often a sign that our map has run out of labels. Cosmologists speak, more carefully, of past incompleteness. Our current models cannot be extended indefinitely into the past. There is a boundary to the reach of the equations, not necessarily to time or being. Something happened before the hot, dense, rapidly expanding phase. We do not yet know what. Perhaps space-time emerged from a quantum foam. Perhaps there was a bounce from a prior contraction. Perhaps a vast landscape of eternal inflation through bubbles like seeds. And ours is one. The point is not to crown a single tale, but to recognize the humility that data asks of us. The Big Bang marks the edge of our present understanding, not a cliff where existence begins from nothing and nowhere. This way of seeing changes the feel of beginning. It isn't a spot you could travel toward. It's the vanishing of the entire surface when you run the film backward. On the balloon, rewinding shrinks the whole skin. There is no special point on the skin where things started. So too with the early universe. All of space was compressed together. Ask, where did it happen? And the honest answer is everywhere. That answer is unsettling because it erases the comfort of a center and a border, and beautiful because it makes the origin universal, woven into every particle, every photon, every galaxy. Time complicates the comfort further. If time truly began at the Big Bang, then asking before is like asking what is north of the North Pole, a direction that stops existing when you reach it. If the Big Bang is only the limit of our equations, than before may have meaning behind the veil of quantum gravity. Either way, the lesson is the same. Time is not the simple, endless line our days suggest. And even if that first moment were absolute, it would be a boundary in time, not in space. You cannot walk to it. The scale factor shrinks to zero in the mathematics. The picture that emerges is not a rim you could touch, but a page where the story begins. Our imagination has long-loved stages with walls, crystal domes, shells of stars, celestial tents. Relativity replaced those with a self-contained fabric, finite or infinite, closed or open, without requiring a larger room. The balloon sketches we still use are helpful only if we remember their trick, embedding a lower dimensional surface into a higher dimensional space for our eyes, not for reality. The outside in the drawing is for comfort, not for truth. From beginnings in time, let the mind drift to boundaries in space and feel how different they are here. A boundary in this universe can be a place where equations fail, or a horizon where cause and effect are rearranged. You don't always meet walls you can tap. Sometimes you meet a line across which signals cannot return. The event horizon around a black hole is exactly that, an invisible curtain pulled by geometry. There is no crust to knock, no rim to scrape. Float across, and nothing special pricks your skin. The sky simply reshuffles its promises. From the outside, though, the difference is absolute. No light you send will arrive. No call will be heard. A boundary of information, not of substance. The cosmic horizon that encloses our observable universe shares this nature. It isn't a shell holding galaxies in. Nothing bounces off. In coordinates that grow with the expansion, galaxies keep their addresses, while the distances between addresses change. The horizon marks how far light has had time to travel to us. It is a limit of communication and knowledge, not of being. And even our maps can lie. In one coordinate system, a black hole's horizon looks like a singularity. Switch to a better map, and it smooths out. The true singularity, if classical gravity is trustworthy there at all, lies deeper. Just as a Mercator map stretches the poles into absurdity, a poor choice of coordinates can turn ordinary places into fake infinities. Physicists learn to be suspicious of edges that appear when a chart is changed. Even the strongest edges in our current theory, the singularities where curvature roars to infinity, may soften under a fuller description. Most of us suspect that a future union of quantum mechanics with gravity will replace those impossible spikes with something finite and well-behaved. If so, then even the fearsome ends of general relativity are more about our partial knowledge than about abrupt cuts in the fabric. It is calming to think this way. The universe does not wear walls, it wears rules. The observable world is bounded by how far light has traveled since the fog lifted, not by a glass sphere. Black holes are bounded by the tilt of light cones, not by matter shells. Where drawings show cliffs, we check if they are cartographic tricks. Where equations shout infinity, we ask whether they are telling us to invent better ones. Boundaries become less like fences and more like the places where our conversation with reality changes grammar. The conversation becomes most dramatic near black holes. From far away, a black hole poses as a round darkness on the starfield. Drift closer, and you feel gravity's hand harden. Past the horizon, and while nothing tactile cries out, your future narrows to a single fate. All paths bend inward. The horizon seals, not with stone, but with law. From the outside, black holes are spare. Mass, charge, spin. That's the no-hair promise. No external memory of what fell in, No ornate signature of a star or a cloud or a person. Featureless from a distance, utterly extreme within. On that line, relativity and quantum theory test each other, sometimes laugh, sometimes argue. Even horizons whisper with temperature. Hawking taught us that black holes glow faintly, leaking their energy away on timescales so long they make patience blush. In a universe where dark energy dominates, the cosmic horizon hums with its own almost undetectable warmth. Horizons are not metaphors. They are physical things with temperature and entropy stitched into the equations. The kinship between horizons brings us back to a different, quieter future, a cosmos where dark energy guides the long arc. As matter thins and expansion accelerates, the large-scale universe settles toward a simple shape known to theorists as De Sitter space. Strip away the clutter, no stars, no gas, no dust, and leave only a fabric whose nature is to expand exponentially, doubling its scale over and over like interest that never pauses. In this model, every observer lives within a permanent bubble of visibility. Beyond the bubble, the world continues without edges, but forever out of reach. Nothing dramatic happens at the rim. The curtain is made of time and distance. Inside, the grand character of what you see hardly changes. Irregularities smooth. The scene is calm. De Sitter space sounds sterile and turns out to be revealing. By removing waves and weather, you can study the tide. Accelerated expansion, cleaned of distractions, teaches how horizons carve each viewpoint into a personal cosmos, finite for each observer, unbounded for the universe. Infinity lives beyond every shoulder and never arrives in your hands. Knowledge is thus local, not as a failure but as a feature. No single vantage contains the whole. The fabric insists on humility. There is a soft paradox tucked there. The universe can be endless overall, and yet every inhabitant is granted only a finite domain. The boundary isn't material, it is causal, and even in this serene end state, the horizon has physics. Like a black hole's rim, it carries a temperature so faint it would shame the most delicate thermometer. It carries entropy, a count of ways the unseen could be arranged. Even in calm, the universe hums. The line from beginnings to horizons loops back with a simple refrain. Where space seems to stop, something else is ending instead. At the Big Bang, it is the reach of our equations. At a black hole's edge, it is the chance for a signal to escape. At the limit of the observable universe, it is the time available for light to arrive. The cosmos is generous with existence and strict with connection. What lies beyond our reach remains, whether or not we know it. Our moment, this warm century, when ancient light is measurable and distant galaxies still write to us, will not last forever. The view will narrow. The play behind the curtain will go on. If that sounds sorrowful, let it also be kind. Knowledge is most alive at its horizons. We stand where explanations must be careful and metaphors must be gentle. We relearn that words like outside and before can be loyal in rooms with walls and mischievous in rooms without. We practice seeing edges as the places where a rule changes, not where reality falls away. We trade the comfort of borders for the comfort of coherence. So picture no cliff at the universe's rim. Picture horizons, some you can never cross, some that drift as the fabric stretches, some that guard the secrets of a singular core. Picture beginnings that are pages, not fences. Picture a cosmos that does not sit inside anything, because inside is part of its own invention. And picture yourself within it, small and awake, living in a bubble of connection that is tenderly finite, while beyond your bubble the quiet goes on and on. If you could empty the universe of everything noisy and bright, and leave the fabric by itself with a gentle pressure woven into it that makes it grow, you'd be holding the essence of that serene model of the future. It would not be boring. It would be instructive. You would watch a horizon settle at a fixed distance for each observer, a permanent outline to a private sky. You would learn that loneliness and limit are not the same thing. You would learn that a boundary can be absolute in what it forbids and still be made of nothing you can touch. And as you brought the stars and dust and people back into the picture, you would keep that knowledge. The Big Bang would stop being a firework and become a universal unfolding. Singularities would stop being certainties and become signposts that ask for deeper mathematics. Black holes would stop being drains and become rules written in the geometry. Horizons would stop being walls and become lines drawn by the speed of light and the tempo of expansion. The edge of the universe would stop being a ledge and become a quiet word for what can be known from here. Infinity can be roomy yet intimate. In a universe that stretches without end, each of us still lives inside a private reach, a horizon that parcels the limitless into a personal share. That is the quiet lesson of De Sitter Space, the simple, serene model where dark energy rules and expansion smooths the fabric until it looks unruffled from every angle. Studying it is not escapism, it is rehearsal. Our observations already say that dark energy dominates the cosmic budget, and with each passing epoch, the large-scale scene drifts closer to this calm. Matter thins, radiation fades, and the gentle push of the vacuum's pressure becomes the only tempo left. Whether that stillness lasts forever or yields to new physics later is an open door, but for now, De Sitter Space offers a clear sketch. Finite horizons set against endless expanse. Steady growth set against regions kept forever off stage. It teaches that no edges does not mean no limits, and that serenity is not the same as simplicity. The universe can be infinite yet veiled, smooth yet mysterious, peaceful and still profoundly strange. Look up, and you're watching the transition in motion. Galaxies that glitter tonight will, one by one, slide beyond our communicable reach until only our local companions remain, stitched together by gravity, while the rest grow dim with distance. The sky will not signal an ending. It will simply grow quieter. The fabric will resemble De Sitter Space more closely wide, unhurried, and endless, with hidden regions sealed away not by walls but by the pace of expansion. There's something like poetry in that vision. The end of conversation is not the end of existence. What slips beyond the horizon is not erased, only kept apart. De Sitter reminds us that infinity can wear a boundary, and that the gentlest future may be a world where horizons endure quiet, absolute, a soft reminder that the cosmos is both inexhaustible and, in a very real way, untouchable. When physicists want to see this logic with their eyes, they flatten the infinite into a picture you can hold. Conformal diagrams, Penrose diagrams, if you like, are the bedtime folds of space-time. At first glance, they look like tidy diamonds, triangles, and squares crossed by a few straight lines. Yet each line carries the rules of causality. Each corner stands in for an infinity, laid carefully on the page. The trick is honest. Don't preserve sizes, preserve angles. Make sure light always travels along 45-degree lines, and you will faithfully encode who can talk to whom. Distances and durations can be stretched and squashed. Causal structure must remain intact. With that choice, horizons, infinities, and singularities become lines you can trace with a fingertip. Take the plainest stage, flat Minkowski spacetime, the version with no curvature and no expansion. In a conformal diagram, it becomes a diamond. The top is future infinity, where time-like paths end. The bottom is past infinity, where they begin. And the slanted sides are spatial infinity directions that never quite arrive, however long you walk. Light rays glide along the diagonals, so the skeleton of cause and effect is obvious at a glance. What felt ungraspable turns into a finite sketch without losing what matters. Curved worlds draw even more meaning onto a small shape. A black hole's event horizon appears as a straight boundary separating the outside from the interior. Cross it, and all future paths point toward a singularity. For an expanding universe, you see a cosmic horizon that marks the region from which signals can never reach you. In both cases, the diagram hushes the noise that words can introduce. It shows where knowledge runs out and why that is not the same as a physical barrier. Infinity, usually overwhelming, becomes a labeled edge within the picture, not a door to open, but a reminder that some journeys do not end in arrival. Spatial infinity isn't a wall you can tap. It's a promise that you can keep going forever. A horizon line isn't a shell of matter. It's where 45-degree paths tip the wrong way, a causal boundary given a place so our minds can honor it. These drawings are not photographs of the universe, any more than a musical score is a recording of a symphony. They're instructions, where light can run, where it must stop, how regions fit together, whether geodesics, the straightest possible paths, can be extended or must end in genuine singularities. They reveal whether a horizon forms, whether an infinity is time-like or space-like, and how different patches of space-time stitch into a whole. In the hands of a working physicist, they are diagnostic tools. In the eyes of the rest of us, they are gentle acts of translation. Infinity is folded, not conquered. Edges are marked, not invented. And the most important choice, keeping those 45-degree light rays true, declares that causality is the backbone of relativity. Stretch the canvas as you like, the beams of light must still cross the page at the same honest angle. The same taste for structure plays out on the largest maps we can make. When astronomers began counting galaxies in earnest, they did not find a uniform sprinkle. They found a web. Filaments thread the darkness like rivers seen from night air. Each strand an enormous chain of galaxies hung on rails of invisible mass. At the crossings sit clusters, bright cities where thousands of galaxies gather, their hot gas glowing, their dark matter halos overlapping into one deep well. And between these structures are voids vast enough to make the heart misjudge. Hundreds of millions of light years across in places, they can look like gaps where the universe ended. They are not endings. They are neighborhoods where matter simply didn't crowd together, places almost but not entirely empty. It helps to borrow an image from foam. The filaments and clusters are like the thin walls of bubbles. The voids are the roomy interiors. The foam stretches in all directions without a container, so there is no bubble where the fabric stops. Step into a void, and you do not fall off anything. You simply notice that the next galaxy is much farther away. These patterns are not imposed from outside. They arise from tiny differences in the early cosmic broth, small overdensities amplified by gravity, while underdensities bled matter to their neighbors. Over billions of years, contrast sharpened, and the web appeared. There is an elegant counterpoint hidden in the complexity. Zoom in, and the universe is intricate. Knots, strands, and spaces in between. Zoom out far enough, hundreds of millions of light years and beyond, and the detail blurs into evenness. The forest, seen from a low flight, becomes a green plain. The cosmic web, seen from a grand enough distance, becomes homogeneous. That large-scale uniformity is not a footnote, it's a foundation. It supports the cosmological principle, the modest claim that we do not live at a privileged center. Our local patch might be a little busier or a little emptier than average, but on truly vast scales, every region looks statistically the same. No secret walls, no ultimate edges, no throne room at the center of all things. This homogeneity coexists with the personal limits De Sitter space teaches us to expect. On the grandest canvas, the universe wears no boundary. From within, every observer has one drawn not by matter, but by the reach of light and the pace of expansion. Conformal diagrams make that logic visible. Galaxy maps make its texture plain. Together they whisper the same refrain. Where space seems to stop, connection does. Infinity is not abolished, it is apportioned. Horizons are not insults. They are the grammar of a universe that prefers coherence to chaos. Voids can play tricks on the heart. From inside one, with only a few faint smudges scattered across a wide black dome, it would be easy to believe the universe stops just beyond your reach. The night would feel thinner, lonelier, as if the world had run out of stars. Keep going, though drift long enough through that hush, and the scenery changes. A pale thread brightens ahead, a filament where galaxies have gathered like towns along a river. Beyond it, another quiet bowl opens, and beyond that, another strand. The rhythm repeats, emptiness, then lace, darkness, then a soft braid of light. The pattern keeps suggesting itself farther and farther without any hint of a final wall. Maps can trick us too. Survey plots often show sharp edges where the data end, boundaries that look like the cosmos drew a line. They are not cosmic fences, they're the edges of our instruments and our patience. Just as old sea charts once left blank triangles labeled with creatures of the deep, our sky maps fade not because the universe stops, but because our measurements do. Past the border of the figure lies more web, more threads, more rooms of quiet waiting for better eyes. What gives the web its quiet force is the way it connects scales that seem to have nothing to do with each other. Filaments, built from the unseen scaffolding of dark matter, gather gas the way mountain valleys gather mist. Inside those galaxies, clouds collapse into stars. Around some stars, disks grow planets. On a few of those worlds, chemistry finds its courage and tries being alive. The thinness of a void and the thickness of a cluster are not just patterns in a map. They are parts of the long story of how matter learned structure, how complexity found footholds. Without the railings of the web, a spiral like the Milky Way might never have taken shape. Without wide, quiet spaces, some histories might not have had time to unfold. The web carries a gentle correction too. What we call edges in the cosmos are often contrasts, not endings. Filaments are strands, not barricades. Voids are pauses, not cliff faces. Step back far enough and even the drama blurs into calm. Homogeneity, that patient principle that says the universe looks statistically the same from place to place on the largest scales, keeps its promise. Zoom out to hundreds of millions of light years, and the knots and gaps soften into an evenness that refuses to pick a favorite spot. The universe can be intricate without being finite, structured without being walled. From a human vantage, the sight would take the breath. Imagine floating above the lattice itself, filaments glowing faintly like slow lightning. clusters sparking at the crossings, voids yawning like inland seas. It looks alive, a nervous system the size of everything pulsing so slowly that a single heartbeat takes 1 billion years. Yet even this grandeur is middle ground. Smaller scales are busy with stars and storms. Larger scales are quiet with sameness. The web is a bridge between bustle and calm, not a fortress and not a finish line. The night that hangs over all this raises a question so old it sounds like a child's riddle. If the universe is scattered with stars, why isn't the sky ablaze? The paradox bears a name from an astronomer who wrote it down, but it haunted thinkers long before. In a universe that is infinite, eternal, and uniformly filled with stars, every line of sight should end in starlight. The whole sky should be as bright as a stellar surface. The answer once leaned on dust. Perhaps clouds sip and smother the light, but dust would warm until it glowed, and the night would still be bright. The fix needed to be deeper. 3 gentle facts put the question to rest. The universe has a finite age, stars have finite lives, and space itself is stretching. With a beginning some 13.8 billion years behind us, only light old enough to finish the journey can arrive. The rest is still on the road. Even if the universe were older than memory, stars are brief compared to forever. They flare and fade. At any moment, most possible stars are not shining. And while the light is coming, the path grows. Expansion stretches the wavelengths, sliding them beyond human vision into longer, colder bands. What might have been a brilliant sheet becomes a soft background wash, the cosmic microwave glow leaving most of the sky dark to our eyes. Night isn't the absence of stars, it is the presence of history. Each piece of darkness says the universe began, that stars burn and stop, that space dilutes the color of distant fire. Darkness, then, is evidence. Between the bright points lies the afterglow of a hot youth, too faint to see without radio instruments, but everywhere. An invisible paint coats the whole dome, proof that the world was once a single fog of light. Philosophers once took the hush as an argument that space must be finite. The modern story says otherwise. Infinity doesn't guarantee brightness. A finite age, a living sky, and an expanding fabric are enough to make a night. Stand under that night, and the next question rises almost on its own. How big is the whole thing? The observable bubble, about 90-odd billion light-years across today, tells you only how far light has come since the beginning. It says nothing about where the web ends, if it ends at all. Here the limits are honest. We have one sky, one history, one vantage point. That uniqueness bakes in an uncertainty called cosmic variance. No matter how carefully you measure the ripples in the ancient light and the spacing of galaxies, you cannot peek past the horizon to check if the unseen is different. The best we can do is set lower bounds. The universe must be at least this large. Beyond that, humility. Even so, the sky gives strong hints. Curvature is one of them. If space has positive curvature like the surface of a sphere, then there's a finite volume without edges. If it is flat or negatively curved, it can be infinite. Measurements of the ancient globe suggest the geometry is astonishingly close to flat, with any deviations smaller than a tiny fraction. If the universe is finite, its size must therefore be enormous, hundreds of times larger than our visible patch. Perhaps vastly more so large that, from here, flatness and infinity look the same. Another hint comes from structure. When you smooth the data on gigantic scales, The patterns become uniform. No bruises near the horizon, no lopsidedness that would whisper of a nearby wall. If a boundary lurks not far beyond what we see, it leaves no fingerprint in the web we can map. There's a difference worth holding on to: conclusion versus constraint. No observation can conclude that space is infinite. Infinity isn't a measurement, it's a concept. What observations can do is fence off the two small options. They can say, at least this big. They can say, at least this flat. In the early universe, inflation likely stretched everything with a sudden, breathless expansion, ironing out curvature and expanding a small patch into something outlandishly large. Some versions make the whole truly without end. Others tie the space into a vast, closed shape that dwarfs anything we can touch. Inflation tells you your window is a postage stamp on a giant canvas. It doesn't tell you how big the canvas is. Where that leaves us is both firm and open. The universe is at least unimaginably vast. It may be finite, so large the loop has not had time to reveal itself, or it may be without limit. We may never know which. The horizon is not a technical gap, it is a principled one. Beyond it, the world might continue as before. It might curve back on itself in manners we cannot test. Uncertainty here is not failure. It is the honest shape of the question, and the constraints themselves are wondrous. From whisper-fine ripples in the microwave sky, we infer sizes beyond simple imagination. From the smoothness of that glow, we infer a strong sameness. From the success of inflationary ideas, we infer that our patch is a tiny fraction of the stage. Infinity carries its own philosophical tug. If the universe is truly without bound, then there may be uncountably many galaxies, uncountably many stories, and depending on the details of physics, perhaps even repeated arrangements scattered beyond any reach. If it is finite but colossal, then the number can still be breathtaking, merely countable in principle. Physicists handle infinity with care. It solves some problems and causes others. The safest answer, with a hand over the heart, is that the universe is already big enough for webs and clusters and long rivers of light, big enough for worlds and oceans and one small species to wonder aloud, big enough to stretch both minds and instruments without breaking either. There is another way the world could be large without being limitless. Imagine a universe that loops back on itself, not with walls, but with seams, so that straight lines eventually close. Travel long enough in one direction and you return from behind, not because you turned, but because space is stitched that way. In such a room, without doors, the sky might hide repetitions. If light can circle, you could at least in principle see your own galaxy from the outside, a ghostly double staring back from far away. You might find the same galaxy in different places at different ages, like a family album scattered across the heavens. Surveys have hunted for such echoes in both the galaxy maps and the ancient light, searching for matched circles and repeated patterns. None are obvious. That means if space is wrapped, the loop is larger than our visible sphere, or the signatures are too subtle for now. Life in a wraparound cosmos would make navigation a gentle puzzle. Send a craft on a perfect line, and someday it might return from the other side, as if the road itself were a ring. Far away would lose some of its weight, because every path belongs to a circle. Infinity would not come from size, but from iteration. The same structures appearing again and again, each copy showing a different hour of the same life. Even without proof that we live in such a room, the thought is a soft exercise before sleep, a way to feel how geometry can erase edges without erasing wonder. Picture yourself drifting in that stitched world. You set a course and keep it. Ages pass. Filaments sweep by like slow rivers. Clusters loom and slip behind. Voids open like wide breaths. The quiet is complete but not empty. Every passage shows a different piece of the same pattern. By the time the path curves you home, the sky you left has ripened. Your own galaxy is older, its stars in other arrangements, its clouds churned. You recognize it, and you don't. You wave at yourself from far away, and both of you keep going. Even if reality chooses a different design, the lesson folds back into the same refrain. The web is wide and has no rim. The nights are dark because the world has a story, not because it has a wall. Our maps have edges. The universe keeps going. Horizons mark where conversations end, not where existence stops. Curvature and topology decide how roads behave, not whether there is a floor to walk on. Constraints can be strong without being final. And in every version, a flat infinity, a gentle loop, a space that smooths into calm under dark energy's hand. The most dramatic structures remain threads in a cloth that never tears. If the size of the whole remains undecided, the meaning of the part we share is not. We live in a room whose ceiling is an ancient glow, on a street threaded to a web, with neighbors we can still see and write to for a while. The horizon is a boundary and an invitation, a place where the known becomes honest about its limits and still leans forward. Whether the universe is endless or loops in secret, whether repeated patterns are waiting just beyond our candle or not at all, the fabric has no need for walls to be whole. The story continues off stage, and that, too, feels like mercy. When the wandering grows heavy, return to simple bearings. The voids that surround are not abysses, they are quiet parks. The filaments are not ramparts, they are roads. The darkness between stars is not failure, it is proof that time is real. The edges on our plots are not the end, they are the limit of a survey. The universe has made room enough for webs, for questions, for sleep. Let the thought of a borderless tapestry be a comfort rather than a cliff. Let the idea of private horizons make infinity feel companionable. And if you ever feel small under all that sky, remember, small is the right size for holding a lantern. The light does not have to reach everything. It only has to reach as far as you are going tonight. Imagine drifting for ages along a straight path, never once turning, trusting the line you chose, the way a river trusts its banks. One evening, familiar star shapes begin to rise ahead, patterns you know by touch more than memory. It takes a while to believe it. The sky you left long ago stands in front of you. The route was not a circle on a map. It was a circle sewn into the fabric itself. Space has joined its own edges without admitting to fences, and you have just traced the seam. Or picture yourself lying under a quiet dome of night, wondering whether some of those glittering points are not strangers at all, but echoes light that ran the long way around to show you a place you already know from another angle, another time. There's comfort in that suspicion. The universe doesn't need to be infinite to feel endless. It only needs to be connected with enough cleverness that every road continues. Astronomers would inherit practical puzzles in such a room. If copies of the same galaxy appear in different directions, how do you tell a twin from a neighbor? Patterns can help. Suspiciously similar spirals, matching arcs of star birth, familiar halos of dark matter might raise an eyebrow, but galaxies age. They shed and gather, they collide and heal, and no two snapshots match perfectly, especially when separated by billions of years. A subtler clue lives in older light. The relic glow from the early cosmos, the microwave aftertaste of a hot beginning, should also wrap, tracing paired circles across the sky, where the same primal patch is seen from two directions. Teams have hunted for those matched circles. Their quiet so far tells a simple story. If space does loop, the circuit is very large. The lack of evidence is not a verdict against the idea. It is only a reminder that our window is small. Even without a detection, the possibility does useful work. It loosens the grip of intuition. Finite does not have to mean fenced. Boundless need not require infinity. Geometry alone can make a world complete and unending at once, like a song that returns to its first theme without ever insisting you stop listening. Think of it as a tale that repeats with variation. Each pass shows the same characters under different light. Repetition doesn't cheapen the scale. It adds layers of connection. The sense of infinity may live less in size and more in the possibility of return. Another word wanders in here and tends to steal the spotlight: infinity. It sounds simple until you sit with it. People often imagine an infinite universe as a flat expanse that refuses to end, a tabletop that keeps going. But infinity is not a place tucked far away. It is a property. It says only this: however far you go, there is farther. It does not promise that somewhere you will bump into an edge of infinity. Any more than counting promises, you will reach the largest number. An infinite cosmos would be a gentle vastness, not fire and spectacle, just an unhurried continuation in all directions, never running out. There's a tempting claim attached to that idea, whispered in books and conversations. If space is infinite and matter can arrange itself in only so many ways, then somewhere there must be another you, another Earth, another night like this, every pattern repeated endlessly. The charm is obvious, the logic is slippery. It trades on the difference between mathematical infinity and physical possibility. Infinity alone does not guarantee duplication. The verdict depends on whether the physics of our world truly limits how matter can arrange itself to a finite catalog of states. If the possibilities are themselves without end, then space could stretch forever and still never repeat exactly. The universe may not be a hallway of mirrors. It might be an endless gallery of originals. Mathematics helps with the tone. Infinite sets are unending, not repetitive by decree. The whole numbers never cycle, and yet they have no last member. Infinity is a direction, not a pattern. Applied to space, it can mean a universe that offers more and more without promising echoes. That distinction matters because it keeps the imagination honest. When cosmologists speak of infinite, they mean our best measurements don't force a stop. The models allow it. Whether nature chooses it and whether that choice brings repetition lies beyond what any telescope can confirm. For now, infinity is a well-reasoned maybe, and even as a maybe, it carries a soft grandeur. To step outside and know that beyond every horizon is another is not to feel lost. It is to feel held by openness. Infinity invites two opposite feelings. One person shrinks before it, another relaxes. Either response is fair. There is a steadiness in an endless world, no brink to fall from, no rim where presence gives way to nothing. There is also a tenderness in imagining our bit of time as a note inside a piece with no final bar line. The melody is not less for being small, it is more itself. Science, which loves repetition and control, finds a different tension in infinity. You cannot test for the lack of an edge by checking everywhere. You can only look farther and find more. That is enough to guide the mind, even if it never delivers a stamp of certainty. If you prefer gentle thought experiments, imagine a voyage through such a world. You pass cluster after cluster, filament after filament. The scenery never cycles. The road never ends. There's always more night, inviting another mile. The journey becomes a way of living rather than a task to complete. Infinity turns into quiet permission. No hurry, no finish line, just the next horizon. Another guest arrives when the topic runs long enough. The multiverse. The word glitters, pulling in images of countless universes stacked like books, each with its own sky. In careful physics, it's humbler and weirder. It's a family of ideas about how our universe might have begun and why its rules look as they do. One branch grows from inflation, the brief, astonishing swell in the universe's first instance. In the simplest sketches, inflation ends everywhere and hands the stage to a hot, dense beginning. In other sketches, it never stops all at once. It winds down in scattered pockets while continuing elsewhere. Each pocket cools into a universe, a bubble in a boiling pot, while the space between keeps inflating, stretching every bubble away from every other faster than any signal could bridge. Our cosmos would then be one settled pocket in a frothy sea. Other branches sprout from attempts to fold all forces into one framework. Some versions of string theory suggest a vast landscape of allowed worlds, each with its own balance of constants and fields. If inflation can plant bubbles across that landscape, then the multiverse becomes a patchwork, where laws vary from bubble to bubble. Evidence, in the usual sense, is hard. You cannot aim a dish at a sister universe. There are indirect dreams, a bruise in the ancient light, where another bubble may have bumped ours long ago, an odd ring in the microwave sky, a statistical fingerprint that refuses to match our simplest expectations. Searchers have looked. Nothing decisive has appeared. A different kind of argument is philosophical. If our universe seems delicately tuned for chemistry and stars and life, a collection of many different worlds allows us to find ourselves precisely where conditions happen to work. Not proof, just a way to move the why here into why not somewhere and carry on. The multiverse does not erase questions, it multiplies them. If bubbles fill a larger process, what set the process going? If a landscape births many worlds, what writes the landscape? Shifting the frame outward does not make edges vanish, it hides them behind further veils. This is why many physicists stay careful. A good theory offers handles you can tug and predictions you can check. By nature, the multiverse resists handles. It stands where science and philosophy read the same page from different ends. Treat it as a serious invitation rather than a settled answer. If other universes exist, they do not make ours less wondrous. They only enlarge the room of mystery. There's a quieter lesson folded into all of this that deserves a little space. Much of what we know is wrapped in careful uncertainty, the cultivated kind that keeps hubris at bay. We never see the universe directly. We gather messengers and translate them. Photons landing in sensors, radio waves whispering in antennas, spectra turned into rows of numbers. Every step introduces noise, limits, chance. One irreducible limit has a gentle name: cosmic variance. We own one sky. There is no second universe to compare. The patterns we map in the microwave glow the tiny temperature ripples that satellites traced with astonishing precision are one roll of a cosmic die. With better instruments, we beat down measurement error. We never beat cosmic variance. It is the uncertainty that remains after you have done your best. Add the stubborn limits of tools. Telescopes live under budgets of mirror size and detector sensitivity. Even in space, Where air cannot blur a view, electronics hiss, heat creeps, time runs out. Photons arrive according to statistics, sometimes bunched, sometimes sparse. On Earth, the sky has its own voices, airglow, weather, human lights. In orbit, the instruments themselves must be taught to whisper. None of this weakens the enterprise. It gives it shape. Science becomes an art of listening beneath the noise, of stating not just what is known, but how well it is known, of marking every map with its honest edge. Astronomers spend as much time listening for the universe as they do listening past themselves. Every mirror hums, every detector crackles, every atmosphere, Earth's or instruments adds its own faint weather to the signal. So they subtract and subtract again, peeling away the hiss until what remains is the sky's quiet speaking. The cosmos is generous, but it delivers its news by teaspoon, always with a little static in the spoon. That's why scientists draw error bars. They aren't apologies, they're promises. An error bar says, here is the range where truth almost certainly lives. Here is how closely we've cupped our hands around it. When you hear that the universe is about 13.8 billion years old, imagine that number wearing a narrow shawl of uncertainty tens of millions of years either side. That shawl isn't a flaw, it's craftsmanship, the sign that the measurement is careful enough to know where its edges are. Absence of evidence deserves its own lullaby. In daily life, we often treat what we don't see as what isn't there. But at cosmic scale, silence is ambiguous. A signal may be too faint. A pattern may lie just beyond tonight's horizon. A method may not be the right kind of ear. The sky's quiet does not prove a war. The lack of matched circles does not certify infinity. It reminds us how far our lantern reaches, and how much darkness is simply distance, not emptiness. There's a gentleness in learning to live with that. The universe does not open itself all at once. Knowledge arrives in nested steps, a contour, then a feature, then a detail. Final answers are rare. Horizons are common. The patience to leave room for both is part of the craft. Picture the cosmos as a book written in very pale ink. Some sentences glow, others fade to smudges. You can read enough to follow the plot, to feel where the story is going. The missing lines tug at you, yes, but the wiser move is not to scribble them in. It's to hold the page to the light and wait for a better lamp. Humility here isn't surrender, it's the engine. Uncertainty prevents us from leaping to tidy conclusions that later unravel. When a new instrument flies, the outlines sharpen. When a new survey arrives, the models adjust. Discovery is more pencil sketch than oil painting lines first, shading later, an eraser kept handy. Sometimes the smudge itself is the message. Think of the Hubble constant, our measure of cosmic expansion whose value depends on the path you take to get it. The disagreement is not just noise. It may be a doorframe. Tension between numbers can be a finger pointing beyond our present map. In that light, the limits of knowing are not fences but thresholds. Cosmic variance, the reminder that we own only one sky, draws a clean edge around certainty. Instrumental noise urges better designs and quieter electronics. Error bars, confidence intervals, upper limits, all are ways of saying we are paying attention not only to what we hear, but to how well we can hear it. Precision, in this world, does not mean perfection. It means honesty with a ruler. If these thoughts are arriving at bedtime pace, let them be soft. You don't have to solve the whole riddle before sleep. The universe itself declines to do so. What we do have is made dear by what we lack, a handful of trusted numbers, maps with careful margins, theories that fit like well-worn coats, and places where the seams still tug. There's a particular kind of beauty in that collection, the beauty of a well-made instrument, tuned but aware of its own resonance. Metaphors help us carry the weight of all this. They are our stepping stones, our little bridges across the river of abstraction. Balloons for expansion, raisin bread for recession, ripples on a pond for waves, the surface of earth for unbounded closure. Each image gives a handhold, each sneaks in a hitch. Balloons invite the question into what does it expand? Because balloons have rooms. Raisin bread lives on a tray in a kitchen. Our universe does not live in something else. Even Big Bang misleads with its fireworks. It suggests a blast from a center into a surrounding emptiness, when the reality is quieter and stranger space itself stretching everywhere at once. At night, the wrong picture can snag the mind. You hear balloon, and suddenly you're wrestling with the notion of a larger room. You hear bang, and you start looking for a center. The trick is not to abandon images, but to hold them lightly, to let them guide without letting them boss. Trade the balloon in a room for a globe underfoot. Walk straight. Never meet a cliff. Loop home without ever leaving the surface. Trade the bang for a tide. Not debris flying, but distances growing. None of these metaphors is perfect. They simply smuggle in fewer problems than they solve. Better still, are gentler questions. Swap. Where does space stop? For what are the limits of what we can see? That one has a clear, living answer. The observable universe, bounded by the time light has had to travel. Swap. What's outside the box? For what shapes could space take? And how is it connected? Now you can talk curvature and topology things. We can test in principle. A shift from stop to shape, from edge to horizon, turns a fear of cliffs into a walk toward viewpoints. Language itself evolves in this direction. Dark energy is a metaphor that's more humility than definition. It names a behavior and refuses to pretend we know the essence. Cosmic web is a picture more than a physics. No spider spun it, and yet the phrase helps you see it. Words like these are scaffolds. They hold as long as we need them, and they come down when they've done their job. By now, the themes of our wandering are familiar enough to feel like home. Space is not a box with walls. It's a fabric of relationships, distances, and durations knotted by gravity, loosened by expansion, stitched by causality. Asking where it stops is really asking where our conversation with it goes quiet. Horizons express that hush. Your past light cone gathers every messenger that has had time to arrive. Your future light cone maps everywhere your light can ever touch. The observable universe is simply the region that has stepped into your hearing since the beginning. Beyond that line, nothing abrupt occurs. No cliffs, no rims, only a silence shaped by time. On larger scales and in later ages, the universe writes another kind of hush. Acceleration tugs galaxies past a future horizon. They don't blink out, they simply slide beyond correspondence. Curvature gives geometry to the hush without erecting a border. A positively curved space can be finite, yet unbounded. A room without edges that still has a total volume. A flat or negatively curved space can run without end. Topology takes a further step and asks how the fabric might join to itself, how straight lines might close without any wall to turn them. If space were stitched that way, light could, in principle, lap the cosmos and show us familiar places from behind. We haven't seen the echoes. If they exist, their loop is wider than our window. And waiting behind all of this is that oldest light, the microwave afterglow. A map so delicate it must be measured with instruments that speak in whispers. From it, we learn that our patch is close to flat, remarkably even, and seeded with the right kind of ripples to grow webs. If there are grand twists in the fabric, they're likely beyond our sight. Inflation, that brief ironing in the first fractions of a second, explains much of the calm and sets the scale of our visible stage. It doesn't say whether the theater has walls. Dark energy adds the final hush, turning horizons into quiet, permanent farewells. Put together, these ideas lean toward the same tenderness. There is very likely no hard edge. The cliff we fear is not in the world, it is in our reach. What ends is contact. Our maps end because light hasn't arrived, or because the current carries what we seek away faster than messages can cross. The frontier moves with time, sometimes revealing more, sometimes receding, always written in the rules, never in a barricade. If you want a last image to take into sleep, keep it simple. Imagine yourself at the center of a deep, still night. From where you rest, an ever-widening circle of light grows, expanding at light's own pace, touching new places as moments pass. Inside the circle are the things that have already spoken to you: nearby stars, local galaxies, whispers from long ago. Outside is not a wall, but a waiting. Some regions will one day step inside and tell you their names. Others will remain beyond reach, not because they vanish, but because the tide of expansion carries their messages away. The circle grows. It never meets a rim, it meets time. Let that be enough. The darkness ahead is patient. It isn't empty, it's possibility. The fabric continues curved or flat, looped or open, regardless of our seeing. Error bars cradle what we know, horizons cradle what we don't. The universe meets us kindly. Enough light to learn, enough night to dream. Hold the metaphors lightly, ask the softer questions, and let the word edge fade into a quieter word: horizon.